Okay, good morning, guys. So today's lesson is slightly different. We're not going to do a live lesson. Instead, I am going to do kind of a live lesson because it's pre-recorded. So we are going to look at the ear today. So the learning objectives, we've got label the structure of the ear, describe the structure and function of different parts of the ear, and explain how the ear is able to hear and detect sounds. And our keywords are over here. So we've got ear canal, eardrum, ossicles, cochlear, and auditory nerve. And then I just thought I'd put this in here, just to have a bit of a giggle, really, or a bit of a smile, to bring a bit of happiness into your day, if you will. Okay, so these are our keywords. So we have a diagram here. Pay attention to this because we're going to label a diagram in a moment. So we've got the ear canal, eardrums, eardrum, we've only got one eardrum per ear, ossicles, cochlear, and auditory nerve. So here is your ear canal, that's this bit here. Then that is your eardrum, this little circular part. Your ossicles are these three bits here. These are semicircular canals, you don't need to know those because they're GCSE level. Here's your cochlear, and it's like a snail, and here is your auditory nerve. Okay, so let's do a quick retrieval activity. So this is based off previous lessons. So we've got, what is the average speed of sound in air? What is the volume of sound determined by? And then you've got this sentence starter here, so just fill in the gaps. So volume is determined by the something of a wave, which is then a measure of the something of particles caused by something. What is the pitch of sound determined by? And then you've got pitch is determined by the something of a wave, which is a measure of how many something pass a certain point in one something. And if a dolphin uses echolocation to find its prey underwater and the sound wave returns to them in 3 seconds, how far away is their prey? So use this equation to work that out. So your speed equals distance divided by time. And how long would it take for a car to travel 3 kilometers at a speed of 15 meters per second? And give your answers in minutes. So that bit's very important. So pay attention to that one. Remember, 60 seconds is 1 minute. And then again, use the equation, speed equals distance over time, to help you. So take 6 minutes. So pause the video here, take 6 minutes, and then I will go through the answers with you. Okay, so let's go through the answers. So make sure you've got a different coloured pen so that you can mark for your answers. So what is the average speed of sound in air? That is 330 meters per second. Remember those units. Put the units on there because otherwise I or an examiner or Mr. Perry won't know what you're on about, what you're referring to with your units there. If you don't include units, you could be going on about 330 meters per minute. And we wouldn't know because you haven't put the seconds on there. So what is the volume of sound determined by? So you've got volume is determined by the amplitude of a wave, which is a measure of the displacement of particles caused by vibrations. So the bits in blue are the ones that you should have written down. So if you got them right, tick them off. If you didn't, then fill them in with your different coloured pen. What is the pitch of a sound determined by? So pitch is determined by the frequency of a wave, which is the measure of how many waves pass a certain point in 1 second. So that is the definition, remember, part of the definition in there of frequency. So if a dolphin uses echolocation to find its prey underwater and the sound wave returns to them in 3 seconds, how far away is that prey? So use this equation to help you. So you will need to do the speed equals distance divided by time. So your distance is 1400 meters per second. You times that by 3 seconds, and then that means your distance is 4200 meters. And then you do 4200 divided by 2, and that is 2100 meters, which is how far away your prey is. And how long would it take for a car to travel 3 kilometers at a speed of 15 meters per second? Give your answers in minutes, or give your answer in minutes, and then use the equation again. So speed equals distance over time. Your time is 3000 meters divided by 15 meters per second. So that means your time is now 200 seconds, and it's 200 seconds divided by 60 because that is your that is the number of seconds in a minute, and that makes 3.3 minutes. So again, tick them if you got them right. If you didn't get them right, fill them in a different pen colour, and I can see that when you hand in your work later. Okay, so now's the challenge, because I showed you this diagram earlier, but now I have removed the labels. So what I need you to do is to fill in the labels. Here are your keywords. So you just need to take these keywords and fill them in with these gaps here. If you really want to, you can draw this diagram or make your books look nice, and it'll give you something fun to do for a little bit. And yeah, so I mean, if you draw the diagram, it's probably easier for you to label, unless you just want to do 1, 2, 3, 4, 5, 6, 7, 1 to 7, and then put in your labels next to the numbers. But I think it's more fun to draw it, isn't it? And then you have to answer this question here. So how does sound from your mobile phone get to your brain? And describe this process using these keywords in your answer. And I'm not going to show you the answer to this question, because I'm going to look through your books, or look at your work after when you've submitted it, and see what you've all put. Okay, so take 5 minutes. If you need a bit longer, then just keep it on pause. Take 5 minutes, and then we'll go through the labels for this diagram. Okay, so if you haven't done this yet, then please pause the video and then we'll go through the answers. So the first one, this one here is the ear flap or pinna. So that is the outside of the ear, and remember it's a specific shape, so maybe that'll help you with your second question, second task here. So think about why it's this shape. Why is it curved like this? And why are they not against the side of it and instead are out slightly? Why do you think that is? And think about some kitchen appliances that might have the similar shape, because that will probably help you. So I'm going to draw something on here. No, I'm not, because it's going to be rubbish. Think about a kitchen appliance that you might use to get something like a liquid into a smaller space. Hopefully that gave you a little hint there. Okay, and the next one, this one here is the ear canal. So that is again still part of your outer ear, because it's going in from the pinna here, and then your sound goes in here. This bit here is your eardrum. So that is a thin membrane, which is it's very thin, it's got a large surface area, and it's very it can be damaged easily. So it's because it's so thin, it can be damaged easily, and we'll come to that later. Okay, the next bit is 3 bits here actually. So it's these 3 here, and that is your ossicles. So these are 3 little bones. They are the smallest bones in the human body, and they are found in each of your ears, and they are crucial for hearing as a whole, because they link from the eardrum up to this part here, which we're going to get to next, and that is called the cochlear. So that is like a snail. So it looks like a snail shell, and then remember that is the cochlear. And then we've got, I guess, this one next. So you don't need to know this one. This is your mastoid bone. So that's just the bone that the ear canal and the inner and middle ear sits in. Yeah, so I should have mentioned that this bit here is your middle ear, and this is your inner ear. So you've got 3 parts to your ear. And then this is your facial nerve and your auditory nerve. Okay, so the human ear is divided into 3 parts. You've got the outer ear, the middle ear, and the inner ear. And the function is to transfer energy by sound into electrical impulses, which are then interpreted by the brain. So here it is. So you would have the same on the other side. And see how far in it goes into your head as well. So your outer ear. So this is this bit here. That includes your pinna and your ear canal. So that is the part that can be seen on the outside of your head, and its job is to capture sound waves. and then the waves pass along the ear canal into the eardrum, and that is what separates the outer and the middle ear. So your middle ear is this bit here. I should have brought this in a little bit further because that's the inner ear. So the eardrum transfers the energy from the vibrations to the bones, which are called the ossicles, and these are here, and they are in the middle ear, and they make tiny vibrations made by sound waves much bigger. And then you've got the malleus, which is connected to the eardrum, and the stapes is connected to the cochlear. So here is your malleus, and then here is your stapes. Okay, so here are some actual human ossicles here. What I'd like you to do for a moment is just to think about, I've already told you two of them, so this one's called the malleus, this one's called the stapes, but obviously those are the Latin names for them. So what I'd like you to do is think about their shape and think about what their English name would be. So what would you call these in English? So this one would be akin to a DIY tool that you would use, that everyone would have in their house for hitting on nails, for example. So that gave you a very good clue there. This one would be found in a blacksmith's workshop, and they make horseshoes on it. And this one here would be something that you would attach to a horse's saddle. So have a think about that and then see what names you come up with, and then we'll go through them. So your incus here, that is your anvil. So that is like the blacksmith's tool that they hammer steel and other metals into shape. Then you've got your malleus, which is your hammer. So I think that's self-explanatory because of the shape of it. And then you've got the stapes, which is the stirrup. And that is the actual size of these bones in comparison to an American coin. I believe that's a quarter, but I'm not too sure. Okay, so the eardrum. This separates the outer and the middle ear. Muscles keep it very rigid. The slightest vibration causes it to move back and forwards, and it has a surface area of about 55 millimeters squared. But the stapes is only 3 millimeters squared. So your stapes is this little bone here, the third bone. And the energy of the vibrations is transmitted through a much reduced area, which multiplies the pressure by about 20 times. So the vibrations are amplified as they pass onto the cochlear. What do you think are some potential problems that you might have with the eardrum? You might have had it yourself, a certain problem with your ears when you were younger, but have a think about that and then come back. So some potential problems then. So we've got the eardrum, as we know, is a very thin membrane, so several things can impact the hearing, especially if it's damaged. Here's an example. So this is an ear infection. This is what your normal eardrum would look like. So it's nice and clear, you can see through it, and it just looks very healthy. And then you've got this one. So see, it's very inflamed, it's very red up here, and it's got like a yellow tinge to the eardrum itself. So that shows a fluid buildup behind it. So that is an ear infection. It can also be called glue ear, or a swimmer's ear. So you can get it when you're swimming, and you get lots of water in your ear. And this one here is a perforated eardrum. So the rest of it looks fairly healthy, but then you've got this hole in the middle. So that will greatly affect your hearing, because all of the sound can go through that hole immediately, and it's not filtered through the eardrum itself. They can heal though, on their own with a bit of treatment maybe. So those are some potential problems you can have with your ears. So let's go on to the inner ear. So that is this bit here. So the energy is passed on to the inner ear, which contains specialized cells that detect vibrations and convert them into electrical signals. These are then sent to the brain, which interprets them. So cochlear is the main bit of the inner ear we're going to focus on. So this is actually an inside picture of one. So it has actually got little hairs in it. So the cochlear is filled with fluid, and that enables sound vibrations to travel much faster than it would in air. And it has thousands of tiny little hair cells which convert the sound wave to electrical signals, and that is passed on to the auditory nerve and then to the brain. And the cochlea is also responsible for detecting and controlling balance. So this is when if you get dizzy, so if you spin around really fast, the water in your cochlea will turn around and move around, and it will make you feel dizzy. So that is how the dizziness feeling comes about. And this is actually an image of a human cochlea and your ossicles as well. So you've got your stapes and then your other little ossicles in there. And these are the attachments to the ossicles and the cochlea. So the reason why you feel dizzy is because your head moves and the fluid then moves around the cochlea and then you just feel dizzy. So that is the reason why. Okay, so now what I want you to do is to fill in these gaps. So a vibrating object such as a trumpet produces something. The something something travel through the air to the something. The vibrating air enters the ear and is funneled into the something something. And the vibrating air sets the something something. The something transmits the vibrations to the something something, which then start to vibrate. The vibrations of the something are a something and transmitted to the fluid in the something. Cells lining the something detect the vibrations and convert them to the to something something, and the something something transmits the something something to the brain. So take 5 minutes just to fill in these gaps. I've given you the first letter to help you out. So off you go. So if we just go through these videos, so these answers. So a vibrating object such as a trumpet produces sound. The sound waves travel through the air to the ear. The vibrating air enters the ear and is funneled into the ear canal. The vibrating air, sets the eardrum vibrating. The eardrum transmits the vibrations to the ossicle bones, which start to vibrate. The vibrations of the ossicles are amplified and transmitted to the fluid in the cochlea, and the cells lining the cochlea detect vibrations and convert them to electrical signals, and the auditory nerve transmits the electrical signals to the brain. So that is how you will hear sound from something outside, and your brain will pick it up eventually through your ear. So last thing then, just have a think about this question. So why might noise cancelling headphones need batteries? Again, pause the video here, write down some answers, and then we'll go through the answers in a moment. So let's have a look at why noise cancelling headphones need batteries. So normal headphones absorb sound, but noise cancelling headphones have to create sound waves to cancel out other sound waves that are being emitted outside. So the energy is needed from the battery in order to do this. So that is why noise cancelling headphones need batteries. Okay, so hopefully that was a useful lesson. Tomorrow we're going to look at the second part of hearing and ultrasound, ultrasonic hearing, and all of the other things to do with ears. And then I'll probably do it as a similar lesson to this one, so it'll be a pre-recorded lesson. And then if you have any questions, just feel free to message me on Teams or email me, or I'll just see your work when you submit it. So have a good day, guys, and see you soon.